We're going to do a cycle example here. This is problem 33 in chapter 2. We have carbon monoxide gas being compressed and expanding. It has 3 states. The problem asks us to sketch the PV diagram, which we started over here, and to evaluate the work for each process in kilojoules. The 3 processes here are written out from state 1 to 2, state 2 to 3, and from state 3 back to 1. All right? We're given the initial state here. The initial pressure is at 5 bar. Initial volume is at 0.2 cubic meter. State 2 volume is 1 cubic meter. This process is a PV equals constant process. State 2, for the process 2 to 3, is constant volume heating. Volume 2 is 1 cubic meter, as given over here. The pressure at state 3 is 5 bar. Process 3 back to the initial state 1 is constant pressure compression. Pressure 3, 5 bar. Volume at 3, 1 cubic meter. The initial state is given over there at 1. Initial process over here. I've already started to fill in the PV diagram. We know the conditions at state 1, 5 bar, 0.2 cubic meter, so that's filled in. As we fill in more, as we know more, we'll fill this in. All right, so let's start over here. We know that PV equals the constant for this condition over here. So P1 V1 equals P2 V2. So we can find P2 here. Right? We know that P1 V1 over V2 is going to equal P2. We can sub in that this is 5 bar times 0.2 cubic meter over 1 cubic meter. All right? So P2 is equal to 1 bar. All right? So we now know that V2 is 1 cubic meter. We know that P2 is 1 bar. Put a dot over here. We know that this is going to be constant. PV equals a constant. So this is going to go something like this from state 1 to state 2. So we can fill this in. All right. Now, the next part asks us to find the work done for this process. All right. So we can start filling this in. We know that the work is equal to P dV. We know that this is going to be C over V dV, right? This is from volume 1 to volume 2. Limits of integration stay through the whole thing. All right? We know from the lecture content that I went over yesterday that this is going to be P1 V1 natural log V2 over V1. All right, we know P1, we know V1, we know V2, we know V1. All right, so we can plug in these values. So let's go ahead and do that. All right, P1, let's convert from bar back into pascals. 5 bar is 5 times 10 to the 5th pascals. That's Newton per square meter. All right, V1 was 0.2 cubic meter. Natural log V2, 1 cubic meter over 0.2 cubic meter. All right? Work that out. We'll get 160,944.8 joules. The problem asks us to solve work out in kilojoules. So we'll move this over. This gives us 160.9 kilojoules for the work of this process. All right? This is positive, so this is work done by the system. All right? Work by the system. Work by system. You can think of this as energy from the system. All right? Next, process 2 to 3. We know this is constant volume heating. There's no change in volume. And we know when there's no change, there will be no work done, right? So this process is pretty straightforward. There's no work done from 2 to 3. We can go ahead and fill this in. From 2 to 3, there's no change in volume. We know that the final pressure is 5 bar, which is up here. So we're just going to go straight up till we hit 5 bar. This is state 3. This is state 2. Right? That's what that one looks like. All right. Let's move on to process 3 back to 1. Constant pressure compression. Right? We can already go ahead and fill this one back in. Pressure doesn't change. We're going to go back from state 3 to 1. All right, so on our PV diagram, it looks like this. All right, our work work 3 to 1. All right, we're going here from V3 to V1. All right, we know here for constant pressure, this is going to be P3, V1 minus V3, right? Final minus initial. We can evaluate this as 5 times 10 to the 5th pascals times 0.2 cubic meter minus 1 cubic meter, right? This gives us minus 400 kilojoules of work. Minus 400 means work on system. All right, so that's energy to the system, into the system. All right? So if you think about the net work of this cycle, there's no work here. From here to here, there was work minus 400 kilojoules. From here to here, there was positive 160.9 kilojoules. So the net work around this whole thing was minus, so change in work of the cycle was minus 239.1 kilojoules for the entire cycle.